Alrighty, so here we are, the speed of light once again. Alright, I've done this before, I'm going to push it again. A lot of you have trouble understanding, keeping things to scale and things increasing in size but staying in proportion to each other. So what we have here is the sun, and here this line is Earth, and these are little eyes, right? This is about what we can see, okay? So we have the sun, and there are 108 sun diameters. These are suns. There are 108 of these little suns in between Earth and the sun. 150 million kilometers, 93.2 million miles, and 108 sun diameters. They are all exactly the same, okay? Now, what we're doing is we're going to look at the 108 diameters. That is always in between the sun and Earth, right? The 108 sun diameters. It never, ever changes, okay? On that note, buckle up. So what I'm going to do, down there's a screw. See that little tiny screw? Right? That, the tip of that is planet Earth. That little green shiny thing on there. Right? So, I'm going to bring you back here to that planet Earth. See that screw, right? It's the globe. Right? So it's in the middle of that. I am now going to move away by 5.4 meters. Because for this exercise, our sun is going to be this. It's a 5 centimeter diameter light bulb. Now, knowing that there are 108 sun diameters in between Earth and the sun, all I have to do is multiply this by 108, and that will give me the accurate distance the Earth would be away from this bulb if it were the sun. This never ever changes. Earth, Alexa, what is 5 centimeters divided by 109?
5 centimeters divided by 109 is approximately 0.4587 millimeters.
0.45 of a millimeter, so just under half a millimeter in diameter. That's what Earth would be, the tip of that screw. And this is going to be 5.4 meters away. That is the perfect to scale, right? Of Earth, sun, and the distance in between. So I'm going to go over here, 5.4 meters away. Okay, from 5.4 meters away. If this were the sun and it turned on, right, according to the science, it's all in perfect proportion to each other. This bulb here would take 8 minutes and 20 seconds to reach that screw. The light radiating from this star, because it travels at a rate of 1 diameter every 4.6 seconds. That is what they are telling you the sun does. So let's see what happens. Here we go. 1, 2, 3. Holy smokes! Let me just check that again. Oh! Of course. But it's only a shed. It's a shed. It's a bulb. Of course it's going to do that this week. What you're seemingly failing to understand, right, is the bulb and the sun are always 108 diameters. of themselves away from planet Earth. It's about the 108 diameters, right? It will never change. It will always have that ratio. When the distance increases by whatever amount, the diameter of the sun will increase by that same amount. If you double it, the distance doubles. If we treble the sun's diameter, the distance trebles, right? If you times the distance in between by 100, do the same with the diameter. It always rises at the same rate. Now, let's just turn this on and get that done. Right, so we started with a 5mm bulb. All right. So this is, right, we'll block that off, because it's just a little reminder of what we're doing, right? So, first one, a 5cm diameter bulb, right? The distance in between is 5.4 meters, right? And Earth, and it doesn't really matter about Earth. In this one, it was a 0.45 of a millimeter, but it really doesn't really come into play because it doesn't matter what size Earth is. If there is eyes there, they're going to see the light at 5.4 meters away, aren't they? Even like an ant or an amoeba on top of an amoeba, they're going to see the light radiating from a bulb that has a diameter of 5 centimeters from only 5.4 meters. Let's multiply it by 10. So 5 centimeters, we go times 10, becomes 50 centimeters. Right? So we now have a light source with a diameter of 0.5 meter, 50 centimeters. Right? So we multiplied it by 10, we multiply the 5.4 by 10, it becomes 54 meters. Right? So in between the light source and Earth is 54 meters. Would we see a light source with a diameter of 0.5 meter, right? 54 meters away? Of course we would, right? So Earth's diameter would now be 4.5 centimeters. Alexa, what's 50 centimeters divided by 109?
50 centimeters divided by 109 is approximately 4.5872 millimeters.
4.5 millimeters. Alright? It doesn't really matter. Actually, I should move that screw because otherwise I'm going to end up screaming later on. Right? It doesn't really matter. All we're concerned is there are eyes looking in that direction. Of course we'd see a light source with a diameter of 50 centimeters from 54 meters away. It's ridiculous to even ask that. Times 10 again. So we've got 50 centimeters, we've now got 5 meters. Light source with a diameter of 5 meters. We multiply the 54 meters by 10, what do we get? 5.4 kilometers. Right, 54 meters times 10 is 540 meters. See, easily done, easily done. 540 meters, right, in between the two. So, would you see a light source with a diameter of 5 meters if you were 540 meters away from it? Of course you would. And how do we know this? It's really common sense, isn't it, right? 5 metre light source, just over half a K, 3 millimetres. Easy over half a K. Let's times it, multiply it by 10. 5 metres becomes 50. So we've now got a light source with a diameter of 50 metres. Times 10, now we get 5.4 kilometres. So, staying in the same, going up the same ratio, staying in proportion to each other, would you see a light source that has a diameter of 50 metres if you were 5.4 kilometres away? Of course you would. Because this thing will go 12, 13, 14, 15 kilometres. Somebody would see it, right? 3 millimetre diameter bulb in here. Of course you're going to see 50 metres. Now, just a quick check as we're going. Alexa, what's 50 metres multiplied by 108?
50 metres times 108 is 5.4 kilometres.
It always stays that same ratio, all right? When we do something to one side, you do it to the other side. It remains the same. What we're going to do now, we're going to times it by 10 again. So 50 metres becomes 500 metres. So we've now got a light source that has a diameter of half a kilometre, 500 metres. The distance in between the sun and the earth times 10 is 54 kilometres. Look, 54 kilometres. Right? Would you see a light source with a diameter of half a kilometre if you were 54 kilometres away? Of course you would. And we know that because this mirror will bounce the sun's light 160 kilometres like this, bang, in a heartbeat, right? 12 centimetre diameter mirror will bounce the sun's light 160 kilometres. 12 centimetres. But what we have is a diameter of 500 metres, right? So what we're going to do now, we're going to multiply it by 3. Where's that little chalk? Well, I am running out of yellow. We're going to orange chalk. Have a chalk emergency. Right, times 3. So we now have a light source with a diameter of 1.5 kilometres, right? Let's multiply this by 3 to keep everything nice and tidy. 54 times 3 is 162. 162 kilometres. And planet Earth, it doesn't matter. Eyes, it's eyes, eyes looking. Now, would we see a light source with a diameter of 1.5 kilometres from 162 kilometres away? Of course we would. The reason I multiplied it by 3 is because this will bounce the sun's light 160 kilometres, over 100 miles, instantly. Bang! There's no delay. See it instantly. But we have 1.5 kilometres. No need. 12 centimetres will travel that 1.5 kilometres. If you noticed, as we've been increasing the sun's diameter, we've been increasing the distance. There is never a time when the sun all of a sudden seems a little bit too far away. It's going to take a long time for the light to reach us, because the distance is growing at the same time the same rate as the diameter of the sun, right? It's always only going to be 108 diameters away. When it was a bulb, of course it radiates instantly. But when it's 1,390,000 kilometers, it's a monster, right? Of course it radiates instantly to a planet Earth that's only 150 million kilometers away. It has a diameter of 1,390,000 kilometers. It's only 108 diameters of itself away from planet Earth. This is what people are failing to understand, right? It's insane. One more example. Now we're going to go to a sphere that has a diameter of 3,476 kilometers. What's that? The moon. It has a diameter of 3,476 kilometers. If the moon suddenly became our sun, we want to know what the distance is, so we multiply it by 108. Alexa, what's 3,476 multiplied by 8, please?
3,476 times 8 is 27,808.
Alexa, what's 3,476 multiplied by 108?
3,476 times 108 is 375,408.
So, if the moon became our sun, right, the correct distance between us and it would be 370,000 kilometers. That is 108 diameters of itself away from planet Earth. Now it just so happens the moon, the average distance that we are from the moon is 380,000 kilometers, isn't it? It's more or less bang on, right? So we don't even need to do anything. Now, the only difference is our diameter goes down to 31.8 kilometers, I think. Alexa, what's 3,476 divided by 109?
3,476 divided by 109 is approximately 31.8899.
So planet Earth would have a diameter of 31.8 kilometers. If the moon were our sun, the distance, the correct distance in between us and it would be 370,408 kilometers. Give or take a few thousand, that is the distance. It's away from us anyway. The only difference is we would have shrunk down to 31.8 kilometers. It's about eyes, not the diameter of Earth. Whether it was 50 kilometers or 2,000 kilometers, if there's eyes on that planet looking that way, you're going to see the moon. Would it be logical to think of the moon taking 8 minutes and 20 seconds to radiate its light to us here? Of course not. So even the 1.3 seconds is ridiculous, right? It's ridiculous. But we're not talking about that. This keeps going up until we get to 1,390,000 kilometers for the diameter of the sun, right? Earth is 108 diameters of that sun away from the sun. It all stays in the same ratio. The 150 million with a 1,390,000 kilometer diameter sun is exactly the same as a 5 centimeter bulb radiating distance of 5.4 meters, right? It's to scale. I know what people are saying, yes, but it's a shed. Of course it's going to light up. Yeah. But it's the solar system. Of course it would light up because the sun has a freaking diameter of 1,390,000 kilometers. It doesn't go 1, 2, 3, 4.6, 1, 2, 3, 4.6 seconds each diameter for a total of 4.6 seconds for each sun diameter to take a total of 8 minutes and 20 seconds to reach planet Earth. People say, where's your evidence? This is the freaking evidence. How can people not see, right? So what's happening is, as soon as the light source, right, gets to, as soon as the light source gets to 299,792 kilometers, right, in diameter, right, from there to there, it takes 1 second for it to radiate its light the distance of one of its diameters, because it has a diameter of how far it travels in 1 second. It's ridiculous. It's absolutely ridiculous, and it's ridiculous to think that a star that is growing in proportion to the distance between Earth and it at the equal rate is going to somehow take 8 minutes and 20 seconds for its light to reach planet Earth. It is so stupid, right? How has it even passed the pub test? Because nobody's thinking about this, right? No sphere on this planet takes 4.6 seconds to radiate the light the distance of its diameter. But the other thing, that 4.6 seconds isn't like a standard thing that all stars take. Because when we get to UY Scuti, it's just so stupid that people would believe this is how light works, right? It really is. It's just a lack of perspective, a lack of the big picture. It's ridiculous. UY Scuti, with a diameter of 2.37 billion kilometers, I think it's 7.7, isn't it? $2,377,000,000 kilometers. UY Scuti. It takes 2 hours and 12 minutes for this star to radiate its light at the distance of its diameter. You'd be watching it for 2 hours and 12 minutes. It's plain stupid. Alexa, what's 2,377,000,000 divided by 299,792?
2,377,000,000 divided by 299,792 is approximately 7,928.8307.
7,928. This is seconds, right? When we divided our sun by the speed of light, we get 4.6, don't we? We divide UY Scuti's diameter by the speed of light, we get 7,928. Alexa, what's 7,928 divided by 60?
7,928 divided by 60 is approximately 132.1333.
132. We turn seconds into minutes by dividing it by 60. Alexa, what's 132 divided by 60?
132 divided by 60 is 2.2.
2 hours, 12 minutes, right? 132 minutes. 120 minutes is 2 hours. We've got 12 left over. It takes UY Scuti 2 hours and 12 minutes to radiate light the distance of its diameter. That is the kind of universe they put you in, right? It's ridiculous. A light source will radiate its light at absolute speed as far as it's going to go, like that. If it doesn't reach you, if you cannot see a light source straight after it's switched on, you're not seeing it. It's not going to travel towards you. It's a myth. It's illogical and it does not make sense. And if people sit down and think about this thing, you'll realize what I'm saying is true, right? Light does not travel after the first phase. You turn something on and it, boom, that's it. If somebody is out of range of this light down there and they're looking towards it and they can't see it, it's not a case of them coming back tomorrow and it will have travelled. They either see it now or they don't see it at all. And it's the same with all light. It's common sense. So there is your other angle, which I have done before, but I did this on a slightly different route. It's about common sense, right? People that can't understand this, I feel sorry for you. But there's going to be loads of people going, you're in the shed with the light bulb. It's your inability to understand this very, very basic method of demonstrating how light, distance and size remains the same as it increases. There is no better way of doing it, unfortunately. But it's about common sense, isn't it? Some of us struggle with the easy stuff. So tonight, it's looking like clear skies, so we might finally get some planets on the go on the phone. Buenas noches. Some things are so obvious. Nearly as obvious as who didn't build those? Isn't it? Somebody today. You stand in the sun for, or in the desert for God knows how long, and you'll get a ridge of, oh, it's just a lack of common sense. It's unbelievable. It really is. All right, guys. Later, peeps.